Hey, g'day, it's President. Thanks for stopping by. Now I'm working on the Stuart Turner 10H engine again today. This is part 3. Now there is a playlist and the link's up above there now. And today we're making the connecting rod, the crosshead and the piston rod for the engine, and I'll fit those parts and we'll see how they turn out. Now the connecting rod is a special one that I'm making. I'm not using the brass part that was supplied in the kit, so it's a little bit more complex than just machining up the brass part that was supplied. But let's stop talking about it and go and do it. This piece of bronze stock in the vise here is going to become the two bearings at the end of the connecting rod. So I'm just going to deck this off and then I'll take a cut down both sides and reduce the width down to 8.5 millimeters. Now the finished thickness of these bearing halves has to be 5/16 of an inch, but I'll leave some stock on there to remove later on in a turning operation. And then I can go ahead and centre fine across the width and edge fine on this end and drill the 4 holes for the 2 bolts that will hold the 2 halves together. Alright, we've got 3 reference edges now and a top which are all square to each other. This edge over here will be cut off later on. Okay, that puts the probe directly over the centre of this edge here, and now I can offset to find my 4 hole positions. Okay, slice this off now with a slitting saw, and then we'll split it in half just with a hacksaw, and then we can invert the 2 parts, hold together with bolts. Okay, I'll cut that in half with a hacksaw now, and then we've got our 2 bearing halves. Well, there's the one you just saw me make, and you're probably wondering why there's another one on top of the vise here. Well, time for some true confessions. When I offset the slitting saw, I forgot to account for the thickness of the saw. So instead of this finishing at 6.35, it finished at 5.35. So you're an idiot, Mark. What are you? An idiot. Anyway, that one's going straight to the shelf of shame. And I did this one off camera, and interestingly it took me 1/3 of the time and I got it done accurately. So we're going to cut this in half now, and this will give us our 2 half bearings. I've got plenty of allowance between these holes here. Okay, now in theory we should be able to put these on top of each other, and the stud should pass exactly through the pairs of holes. So that's actually quite nice. They pass through there without any trouble at all. So what I can do now is machine these as a pair. Yeah, get up there where you belong. there's our big end bearing. Those two little pins are just throwaway pins I made just to align the two halves. And this gets put aside now until we finished off the connecting rod. This will get bolted back in place and we'll finish turn the outer diameter of these two pieces of bronze. I've done a supplementary drawing of what the steel part of the connecting rod is going to look like, and I've got metric and imperial units on that drawing. And my initial idea was to make this out of cylindrical bar stock, and my reasoning for that was that this part here is more or less cylindrical. But when you look a bit closer, you realise that the two ends are roughly rectangular. Now, making the two ends on their own out of cylindrical bar stock is not hard, but you need to be sure that the axes of the pin that fits through the top of the connecting rod and the bottom where it fits over the crank pin, that they are aligned exactly to each other. So in order to do that and be more reliable, I'm going to make it from this rectangular steel bar stock. Now this is almost the correct size. I've already got some scribed lines on here in centres just as a bit of a sanity check. I've got some extra material down this end to grip in a 4-jaw chuck. The bronze part of the bearing will fit in place of that later on. So I'm going to head over to the mill and we're going to size the two ends, get them roughly to size, and then we'll worry about the middle bit later. That gives me a centre that I can use when I'm setting this up in the lathe. I've also got the two centres for the studs that hold the bearing onto the end of the connecting rod. So this is basically the big end of the connecting rod. This stock is also brought down to 1/4 of an inch thick, and that suits the bearings that we're going to bolt on here later. So I'm going to turn this around now and take care of the other end, and I'll also put the slot in it which mounts over the crosshead. You can see I've machined the other side of that now. Now, as it turns out, the thickness of this steel here is exactly right. It's 11.91, which is 15/32 of an inch, and that means I don't need to do any machining at all on that surface there, which I thought I'd have to do. So what I'll do now is turn this on edge. I'll machine the slot in the end of the connecting rod that fits over the crosshead, and then we'll head over to the CNC milling machine. We'll put in that little detail there, that circular boss. I did a 1/4 inch slot here, 6.35 millimeters with a 6 millimeter cutter. So I just sort of nibble down the center and then offset by 0.17 either side of center. So that gives me a nice smooth wall on both edges of that slot. The end radius isn't really 1/4 inch, but it's close enough. I'm set up in the CNC mill now, and I've used my probe to find the center of the device. So I've gone across the 2 jaws here, then I've offset from this end of the stock to find what will be the center of the wrist pin or the yoke end of the connecting rod. So I'm going to center drill, and then I've got to drill through for a 5 BA thread on the bottom side and then 5/32 on the top side. And then I've got a tool part set up that should do the profile of that end of the rod, and I'll show you on the screen before I start. Well, that takes care of that threaded hole now, and the clearance hole on this side will take a special bolt later on. Now, I did have to machine away a little bit more material from this piece of stock here just to provide clearance for a 4mm carbide end mill, just so I don't sort of run into problems when it plunges down to do the cut. I am going to have to cut from both sides toward the center, just for convenience really. But I've got an end stop set up here so we can swap the part over, flip it over, and then machine the other side, and hopefully it all lines up. So there's our tool part. That'll actually be 2 parts. So we're going to do this circular profile first. It's very shallow, and then we're going to swap over to this other profile here. Now I know that seemed painfully slow, and I was only using a feed rate of 75 millimeters per minute, but this is a very light machine. You're better off to go slow rather than break the cutter or destroy the part. So I'll clean this up, deburr it, flip it over, and we'll do exactly the same machining operation on the other side. Hopefully everything matches up. So I'm going to set this vise stop against that bottom edge of the part. I'll lock it, then move it out of the way, flip the part over, and then bring this pin up to the top surface here and set it again. And that way we'll get our X offset correct, I hope. Alright, both those sides seem to turn out concentric, so I'm happy with that. And what we need to do now is get on the lathe and start cleaning up this centre section. Okay, I've just set this piece in the 4-jaw chuck so that the centre drill mark that I made while this was in the Bridgeport mill is now running on centre. So I've been able to check with the dial indicator across the two faces here, and I've got all that dialed in correctly. So I can start the lathe and show you. I'll put it in gear. So that's running nice and true, and what I'll do is I'm going to machine this section down until it's cylindrical or nearly cylindrical, and then I can flip it around and grip it by a collet or a 3-jaw chuck. Now these two little cuts here, you didn't see me do those, but these actually show me the position of the end of the connecting rod. So all of this stock here is actually waste, it'll come off. So this is the very end of the connecting rod, this is the very top of the flange that attaches to the two bronze bearings. So they're just sort of like reference marks so I know how far to machine to. So I'll go ahead now and get this all cleaned up and make it cylindrical. I'll get a diameter on that and bring it down to the same as this thickness here, so it's fully cylindrical or nearly fully cylindrical. So you can see my drilled holes are still there. I drilled deep enough to make sure that they were still present after I machined all this stock off here. And I can still see my witness mark here, so I'll set up for that. Face it off and then we can flip it round. Alright, we can turn this around now, we've got something decent to grip onto. Okay, there's the setup. This little disc in the end of the yoke here is just a throwaway part, and it's to give me some tailstock support. There's a lot of material to come out of the middle here, and it's an interrupted cut, so really need to have some tailstock support to do that. So I'll go ahead now and get this down to a cylindrical shape in the middle, and then we'll set over the taper angle for the rest of the rod. Okay, I think you get the idea. I'm going to have to swap out this diamond tool holder though. The back corner of that is hitting the head of that bolt. So I'll get a different geometry tool in there and get rid of the rest of that material. This end is taken care of now, it's all cleaned up, it's the correct diameter at the base of the cylindrical section of the connecting rod, and what I need to do now is worry about this top part. There's a lot of shaping that needs to go into this, there's some big radii, and I've got to get the taper in the middle part of the rod here. So it's getting flimsy, so it's going to be fun. Certainly exciting anyway. I've got the compound slide set over to the correct angle now to give me the tapered section in the center of the rod. So I'm just going to keep working away at this. The shape that I end up with down here is not going to be exactly the same as what you see there, but it'll be a very close approximation. So I'm just going to work away at this, and I'll bring you back when I've got that center section complete and the roughing out of this top part. Well, there it is. I got through that without mangling it, and I've done a bit of polishing work in the center here, but it needs more. And I'll need to do some work with the file just to blend the circular part of the eye with the top of the yoke and get rid of those little sharp corners. But overall, quite happy with that. I think it looks 10 times better than the brass one. Certainly more authentic anyway. I think that's the right term. Authentic. The very last step in machining the connecting rod now is to put a 3/4 diameter on the bronze bearing here. Now I'm gripping it in a forge or chuck at the top end here using that little aluminium disc I'd made previously, and I've dialed it in to run true, and I'm supporting the bearing end on a tailstock center. Now I've drilled a center drill mark in the center of the bearing and drilled that right through, in fact, and I'll use that as sort of an oil port later on to inject oil into the bearing. So I'm just going to take very light cuts. No need to go mad with the depth of cut because it could all go badly wrong at this stage, and we don't want to see that. Yeah, that's nice. I'm just going to put a tiny chamfer both ends and we're done. I want to go ahead and make the crosshead for the engine now, and this piece is a brass pressing of some sort, and as it turns out it's already sized correctly across the thickness there for the connecting rod, so I don't need to do any machining in that slot there. So all we need to do here is to face it to length and machine the outside diameter and drill and tap 5BA for the piston rod. This little spigot here is going to be handy for holding it, but that will be cut off later. I'll just grip that with some clearance in the back there so I can get a parting tool in there to finish, and that will separate the crosshead from the spigot. That's it. That was the last 20 microns. I made this part off camera. It's the piston rod. It's very straightforward. It just has a 5BA thread at both ends with a very small thread relief. And later on I'll drive this in hard and it will come up against the shoulder of the thread relief and keep it concentric. So what we'll do now is we're going to part this off and take it over to the mill, and we'll just drill the cross hole for the bolt that fits through the eye of the connecting rod. So roughly like that, about there. Alright, we'll go over the mill and drill a cross hole. Okay, that's it. Partly assemble, we'll get the rest of it together, and then I think we're finished for today. Just to finish up today's episode, I thought I'd show you the parts of the motion that have been completed to this point. I did actually assemble this yesterday, and I just motored the crankshaft around with a cordless drill. It all seems to run fairly smoothly. And there was in the kit a pin which was already supplied. Didn't need to machine it, but it connects the fork of the connecting rod to the crosshead. So I just simply screwed that in, and that was done. So let me get this assembled into here and I'll show you, and then we'll talk about the parts coming up in the next episode. Well, there it is, and I don't have the flywheel keyed to the crankshaft yet, so I'm just having to turn that over with my fingers. And it's a little bit tight, but that's always the way when you assemble these things for the first time. So overall, really happy with what we've got so far. And I think in the next episode I really need to get this flywheel keyed onto the crankshaft, so we'll have a look at that. So coming up in the next episode, we'll have a go at doing the cylinder casting, and these two pieces of stock here are for the top and bottom cylinder covers. And initially I thought this stuff was steel, but looking at it now, I think it's a product called Durabar, which is a continuously cast iron, like a malleable iron. I've used it before, it's really nice stuff to machine, and this piece of brass stock here is for the piston. So that's all coming up in the next episode. Well, that's it for today. Thank you very much for watching, and thank you for the comments that are coming in about this engine build. Now, initially I thought this whole series would have a fairly small audience, because I think it's a bit of a niche topic, I guess, making small steam engines. But the general consensus in the comments is that people love seeing the chips coming off the metal, they love seeing the setups, and I think the idea here is that the skills that you learn from making a small engine are transferable. So, you know, making a connecting rod for a small engine can be translated into making a small part for another machine. It doesn't have to be a steam engine. So that's what I'm trying to do here, is just to show you different ways of doing setups and different ways of making small parts and getting some degree of accuracy with it. And interestingly, when I looked at the notes for the build of this engine, they said that you could build it with just hand tools. Now, I'd love to see that. I do remember in the old Model Engineer magazine, the British Model Engineer magazine, there was a model presented as a serial called Handmaiden, and the entire engine was made with hand tools, no lathes. It was all done with sort of just hand drills and files and just simple jigs and fixtures. So yes, it can be done, but certainly having nice machines does make it easier. Alright, thanks again for watching. I'll see you in the next episode, and it's Prezzo signing out. Cheers.